Welcome to Statistical Engineering Seminar.
Cool.
Freeman, and along with my colleagues at NASA, we've organized this seminar to talk about statistical engineering and approaches to how we can improve statistics and testing and collection of data for large, complex systems that we deal with in the DoD and NASA. It's a pleasure to introduce today's speaker, Dr. Catherine Warner. Catherine Warner has served as the science advisor for DOT&E for the last 7 years. Before she was at the Institute for Defense Analyses, she was the lead for the Air Warfare Division. She worked on numerous types of programs, including UAVs and the F-22 operational assessment. Prior to that, she had experience at Lawrence Livermore, and one of the motivating reasons for this webinar today, we have recently learned that Dr. Warner will be leaving us to move on to bigger and better things over in Italy, working for NATO. She will be directing an undersea warfare research lab. We're excited to have her here today to share her lessons learned and experiences over the past 7 years as a science advisor at DOT&E and all the changes that she's been able to influence. So with that, we'll turn it over to Dr. Warner. Oh, and a few admin notes. We have working questions, so if you have any questions while Dr. Warner is speaking, please put them into the Q&A box, and we'll have a little bit of time at the end to answer those questions. So please feel free to do that whenever they pop into your head, and we will leave time at the end for questions.
Great.
With that, I'll turn it over to Dr. Warner.
All right. Well, thanks. Do I do the slides here?
Yes.
Okay.
Yeah.
All right. Just making sure I officially test the setup here before I get started. Thank you, Laura. Everyone, thanks for calling in. I just want to say that it's really been pretty much exactly 7 years since I started this job as the science advisor at DOT&E. And as Laura mentioned, I worked for many years as an analyst for DOT&E at IDA. When I came into government directly working for DOT&E, my interactions with the entire T&E and acquisition community changed significantly. And basically, it's my interactions with you, everybody that's here on the phone, that have made things happen and I guess, as we'd say, move the ball down the field. So it wasn't me, it was you. And so I wanted to really express my sincere gratitude to all of you for all the significant improvements that have been done in both the design, conducting, and editing and reporting test and evaluation. It's been a team effort, and I'm really honored to have worked together with all of you. So I think I'm going to skip to slide 2 now, just to give you sort of an overview of what I'm going to talk about. Basically, I'm going to explain for those of you not in the DoD testing community. I'm going to say, what is testing? Why did we need to improve it? What did we do to improve it? What were the results of those improvements? And basically, what are we still going to keep doing? So let's go to slide 3. And, well, the United States Department of Defense acquires some of the most systems in the world. And not leaving you out, NASA, because your systems are just as complex and you actually have much smaller sample sizes than we do. So don't feel left out if I don't always say NASA at the end of DoD. But anyway, DoD acquires these complex weapon systems, and they're extremely diverse. So we have ground combat vehicles, submarines, fighter aircraft. Some systems are basically all software, enterprise resource management systems. Some systems are single use, like a missile or a bomb. Systems these days are fairly software intensive. But each of these systems has to be evaluated to determine whether or not it is effective in enabling military users to accomplish their mission. And that is the gist or the goal of what we wanted to applying scientific methods rather than just this is the way we've always done it. So on slide 4, I have a timeline here. Again, this is just a brief overview for those of you not familiar with the DoD test paradigm. So go test and evaluation throughout their development. But in early stages of development, and justifiably, they're focused on the requirement specifications, and subsystems. So, first you just have a little, system, and then you might integrate it into a bigger system. And all along, you're testing it to environmental specifications. You're doing sort of really accelerated life cycle testing, really technical specification types requirements. That slide 4 was a little bit of a build there. So operational testing is actually the last event before fielding to combat users and before committing large amounts of money to the full rate production. And this operational test event is quite different than the previous testing that's been done on the system. It's under realistic combat conditions. It's done with actual typical operators and maintainers, military operators and maintainers that would be use system in combat. And the test comprises assigning missions to units to conduct missions in the expected environment. So there may be one or more environments that they're required to operate in, and against the expected threat. Chart 5 at here problem with requirements documents that we've been using up to this point for the developmental testing and the contractor testing is that these requirements documents don't always talk about the mission. This picture on slide 5 that I'm showing you is a P-8 aircraft on the right and a P-3 aircraft on the lower left. So the P are both maritime patrol aircraft. The P was bought to replace the P-3, which was aging and having low availability. And their basic missions are the same, to do things like anti-submarine warfare, ISR, intel surveillance and reconnaissance. But the requirements document, and these are the operational requirements document, had the primary requirements, those requirements that wanted by the system if it didn't do these things, were reliability, did it have survivability suite, did it have comm suite, and the number of torpedoes and sonobuoys. There was in the requirements where a squadron equipped with a P-8 could find and kill enemy submarines. When in a case like that, and that's often the case, it's up to the operational testers, the Surface Operational Test Agency, and DOT involvement to come up with the missions and criteria that we're going to use to evaluate that, and how we're going to characterize the environment and the threat over which we're going to do those missions. So on slide 6 is an often used schematic that I have to sort of show this threat and environment spec. This is where we're trying to basically characterize system performance across this whole environment. So on the left side, from the bottom green up to the top red, I've put here the environment. So this would be, this particular example is for submarines. So definitely the environment of whether you're deep or shallow is very important to that system. And then on the bottom we have, what is the threat? I call it here the target, but it's basically what is your threat. And so on the far left we have a fairly easy system, and then all the way on the right we have the hardest system. So we don't really want to know just one point in the middle there, which is probably how the requirement was written. Probability of kill a certain sort of threat, that's going to be right in the middle. We're not looking for just one point during the OT and then saying whether or not we met that threshold. Actually wanting to characterize performance, because in real life the system is going to be operating in many different environments. So we want to be able to design a test basically that spans as best we can represent in real life this operational area. The little ovals that are shown on here are actually the different tests because, clearly we can't do all this in one test, and also how we were able to average, for example, this was the Virginia OTTE, the Virginia-class submarine, but some of the test points that we used had used the sonar that was on the Los Angeles-class submarine, so we're able to leverage from there to sort of cover this environment. And this type of part we did very early on when we were looking at, how can we do better. This is how experimental design, if we look at the situation this way, it helps us figure out which points are important and how to span them efficiently. So I guess you might be asking yourself, since, doing, why did we start doing operational testing? Was there something that DoD to go to this type of testing? Because I'm not sure that other countries actually do this testing against, as real as possible threats in, difficult environments. I just want to give you just a little tiny history lesson here. So on slide 7, in the early 80s, Congress was getting quite concerned about our weapon system performance. And on the left slide here, I'm actually showing you a picture of an F-4 firing an AIM-7 Sparrow. And during the Vietnam War, Rolling Thunder campaign, which was in the late 60s, 1964, 1968, naval aviation had a very poor performance, and they suffered over 50 combat losses, at the end of which the C&O ordered a review of, what happened, why weren't the missiles working, why, by the way, the F-4 didn't have a gun, the only thing it had was this AIM-7. And Captain Frank Alt, who was the CEO of the Coral Sea, which was the aircraft carrier that suffered these losses, conducted this review. It ended up being called the Alt Report. And it, numerous issues, both in training and also in system performance. There was problems with the rocket motors, with the electronics. I think the biggest issues they found was that when these airplanes or fighters went out on their missions and came back, even though they're, doing this catapult launch and, difficult recovery on the carrier, they never changed. If you didn't fire the missile, they didn't change it. And when they looked at, for example, Air Force F-4s flying using the same weapons, they also had sort of poor reliability, but not as bad as the Navy, because they actually, like every 10 swords, would take the missile off and check, the electronics to make sure nothing had happened there. So this was in the late 60s, and after that, the services all started doing operational testing. So the service operational test agencies have been around in some form a lot longer than DOT has. But if you switch over to the right side, this is a picture of the Sergeant York. That's also known as DIVAD, the Division Air Defense System. This was under development in the early 80s. It's a self-propelled anti-aircraft gun, and its mission was basically to accompany M2 tanks and protect it against Russian helicopters, which was an emerging, urgent operational need type program, is what we would call it today. And what they did was they took these M48 chassis, which they had tons of them, sitting around, and put on it these Bofors twin 40-millimeter anti-aircraft gun, and they used an F-16 fire control radar. And then the Army decided, well, this is all, off-the-shelf systems. We don't really need to do any development or testing. So actually, when we went out into the trials, it's such poor performance. For one thing, there's a way that the M48, with that huge amount of slotted to the top of it, could even keep up with the M1 or the M2. The control radar from an airplane had some trouble with clutter, coming from the ground, looking up. It was the trial for a disaster. So at this point, the Secretary of Defense Weinberger ordered field tests and ordered an office called DOT&E to report on this system. So we go to slide 8, we'll see that time frame, actually 1983, Congress established DOT&E separate from the service operational test agencies, and it gave DOT&E specific authorities in Title 10 that were to look at the operational effectiveness, the operational suitability, and the survivability of systems before they were fielded to combat. This build slide, so you can go to 9 and see there's the service test agencies, and this shows that DOT&E actually reports directly to Congress, and which, by the way, after the Sergeant York test and the first director of DOT&E, Jack Kring's negative report, and Weinberger canceled the program. But I have to say that because, most of the time programs do not get canceled because DOT&E might have a negative report. It's actually, what I meant to say earlier is actually finding problems and testing is exactly what we want to do in a functioning acquisition system, because you want to find the problems before the system's fielded and be able to fix them. Or can't fix them, with the system that you have. At least the combat knows and has workarounds or can alter their TTP. So we actually do want to find problems. It's going to cancel your program. That was just a really good example. And by the way, if you haven't seen the movie or read the book, The Pentagon Wars, is actually a very good description of how the DOT&E office actually came into being. Chart in this section is another build chart, slide 11, and then slide 12. Again, repeating what I said is that finding problems and testing is a good thing, because that will give us time to correct them or to have workarounds developed. The output from the operations community is providing factual, defensible information to decision makers and make the decision on whether or not these problems worked around, or whether the system should stay in low reduction for a little bit longer. So that's what we want to do when I say we're trying to improve operational testing, is we just want to be able to provide defensible, factual information, and then clear enough that the decision makers can what their risks are. So I guess on this all along, I'm on slide 13 here, improving operational testing. So why did we need to improve it, since we'd been doing it for 30 years, over 30 years in 2010 when I started, and over 30 years for the services? Why in 2010 did we need to change? I found a good quote today from Sun Tzu: if you don't change direction, you may end up where you're headed. I think that, with the complexity of systems that we have, and the system of systems, and not being able to test every single thing because of, the restrictions on our ranges, that being able to efficiently test and do it and defend why you need a test to be that big, or if you're restricted in how much testing you have, what are the best points to get. Those are the things that we were trying to improve in operational testing. So slide 14 is a perfect example. This is what we looked at back in 2010. DOT&E did a BL on the Growler, the EA-18G. So on the left chart, you see that we reported a comparison with the Prowler, the EA-6B, and then the EA-18, which was replacing it. On the left chart, we see a comparison. An actual chart was in our report to Congress. Now, the first thing that we would want to do is, we have no idea how many, how big was the sample size, what was the precision with which we measured. And so just simply having error bars is something pretty simple that you could do and actually show whether or not there was a difference between the Prowler, or actually just to show how uncertain you are with the particular measurements. because of the, I mean, certainly calculating errors is not science, and then you can do it in Excel if you can't do it on your calculator. But computing and software improvements did make using advanced statistical methods much more accessible in this time frame. Slide 15, in 2010, this was in October 2010, this was right after I started working for Dr. Gilmore. He sent a memo on using design of experiments and operational tests and evaluation. So the National Academy in 1998 said we should be doing this, the DoD community, and actually all the OTAs signed a memorandum of agreement, I think in 2009, they would all, start using design of experiments. Nobody really knew, how do you do design of experiments and operational testing? So this very simple memo actually just basically outlines sort of the scientific method. What is the goal? What are you looking for? Our goal is, characterize system performance. Then your mission-oriented response variables. Get back to my P8 and my versus the P3 example. We would want to find things, what's important to anti-surface warfare, or what's important to ISR. And most, I don't have this in the memo, but we also went into, after this, if you a continuous response variable versus a probabilistic response variable, you could actually do a lot more efficient testing. And so we did a lot of work in that area. And then what factors affect those? And basically, operators, the operators that we have at the OTAs, the operators that we work with that are going to be using the system, the active duty people we have at DOT, they're the ones that should know, hey, this is a submarine, this is a missile, this is an air-ground missile. They should know, well, it's going to be altitude, it's going to be time of day, it's going to be clutter. I mean, those are sort of basic factors that you should be able to come up with very, very early in a program, even before you know what the system looks like. The method for varying the factors, ideally across DT and OT, I'm not sure we've actually gotten to the major campaign of using, starting with a DT to do screening and then, maybe being able to do a smaller OT with less factors. That still is the goal. And reporting on them with actual power, or reporting on them with actual measures of merit like confidence, or in designing the test, you could use a power statement to say, okay, I have enough power to actually measure all these things, and if you don't, then maybe you should post some of the factors to another test, because if your power is really low, it really might not be worth doing that test. So that was really very simple guidance that Dr. Gilmer set out in 2010. Didn't do it, didn't actually say you have to do it, this way and put an Appendix A in the temp and things like that. But we all figure out, well, how are we going to do this? So if you switch to slide 16, there was an effort on my part and many other people on the implementation of this memo. And I remember I was talking to Laura about this yesterday, but before I even started at DOT, I met with Jim Simpson and Steve Shamble, who was at AFIT, and they met with me knowing I was coming into DOT and the cafeteria of the Pentagon. And on the back of the napkin, literally, we sketched out it would be a great training plan of design of experiments to the DoD, because basically the Force was already out in front of this, and Air Force Materiel Command was funding these DOE classes across the community. And looking back on it, there's different levels of training for a person that's actually going to sit down at JUMP or StatEase or Design Expert and actually design a test versus, the CO, the head of your OTA, or the 4-star that's in charge of your Materiel Command. What you need to understand of what is this design experiment that I keep hearing about, and why do we need to do it, and is it going to cost more, or is it going to cost less? So those are the kind of questions they want to know. So there was definitely the can for the training of what is DOE, sketched on the back of a napkin. Closely along with that is a research consortium that I started with TRMC. We basically funded 4 universities, Arizona State being Doug Montgomery, who wrote the book on design of experiments, AFIT and Air Force Institute of Technology and Naval Postgraduate School, to military perspective in there, and Virginia Tech. That is now 8 universities. So it's grown over the years. They started the foundations for us. So we had an off-site meeting. It was here at IDA. I remember that very specifically. And NASA was involved with this. Pete Parker came, and Rue was here, and statistical engineering was a term that they used. So that, I mean, I very clearly remember that off-site meeting, and the professors were here from the research consortium, and at that time, this was, I guess, 2010, one of the things we argued about was using the term DOE. It had really bad reputation for some reason, I don't know, associated with Lean Six Sigma or something like that, but people did not take to the use of the term DOE. So we actually spent time coming up with another name to call it instead of DOE. One of the names that's kind of stuck that DTNE used was Statistical Test and Analysis Techniques, which conveniently had the acronym STAT. But we, I think, continue to use just scientific test, scientific methods, scientific test design, just to sort of get away from the whatever bad visceral reactions people had against DOE. And eventually we formed a core team and developed a charter, actually found a charter as I was cleaning my office out recently, which is basically the problem statement with adoption of best practices across all services throughout this joint working group. And the joint group, I found that too. My nice little color-coded Excel chart had OE, IDA, and then Army, Navy, Air Force, Marine Corps, academics, just SOCOM. And that whole team, we had basically telecoms, where we would share our problems, our concerns of how were we doing this right, and also our successes. In parallel, along with this, we continued working with NASA. We have these webinars, for example. We wanted to workshop right away, but I think the first year was bad news for DoD and going to conferences. But actually, we did get the workshop in 2016, and it was very successful, and we had another one in 17. Happy to announce that we're having another one this year in 2018. So that partnership with NASA and those workshops have been very popular because it's actually the analysts coming ending from each other. Other foundation for improving test science and operational testing is the training. So develop specific training courses for officers and for the OTAs to include specific examples of types of systems that we were looking at. So next chart, 17, the build, my puzzle piece. These are the tenets that we came up with from the charter. These were the key pieces that we needed, starting bottom left, the green temp test plan report guidance. That was, the strong leadership of Dr. Gilmore. I guess strong good word, but still having top-down leadership helps, and guidance helps. We came up with a temp guide, and we've updated that. We're up to version 3.1 now on our website, and it has examples of how to do these different things that we're looking for. Education and training. I just mentioned we developed specific courses for operational testing that uses real case studies, And we also expose the community to what university degrees are available, both in statistics and at Appet, where they have the T&E certificate, which can be an online academic. Right, we have case studies and best practices. So that's more of the bottom-up type of institutionalizing this practice. And every month, we would have these teleconferences in my office. Invited each service to take and bring a case study, whether it worked or didn't work. We would present that, and the actual roadmap that I put together was like almost 2 inches thick of case studies that we came up with or recorded. And finally, on the bottom right, we had an advisory board. We always talked about, ask the professor. We needed a website. We needed a link that said, ask the professor. We have that actual link yet, but we do have an advisory board. Those are the professors at the universities, and I've been to have not only producing students that actually come into the T&E workforce, but also answering some of those really tough questions for us. Again, just expounds on the case studies that we compiled. Everyone participated. I can't thank enough. I mean, my office holds 5 or 6 people, but we would have 14 people in my office every time we had one of these meetings. ATEC, I know, would always drive all the way down from Aberdeen just for the 1-hour meeting. Everyone else, participated over the phone, and really, I think we're able to share among the different services their good, the good and the bads, and what is T&E making us do, and how can we do it, get our temp signed. In 19, you've probably seen this before, but this is the roadmap. I don't know if I should say this is the roadmap, but this is the adjustments, I guess, that we made along the roadmap. And so we can look at that. DOE memo was published in 2010, and we had the test science roadmap. We had additional memos. DT&E stood up the Center of Excellence, which has actually been very successful, aimed at the acquisition community than at the test community, but that's convincing PMs and PEOs that they really need to do test science and their testing, early contractor and developmental testing. We had memos on the application of DOE, security. We had many memos on the use of surveys, which I'll talk a little bit more about. And recently, we've had a couple on modeling and simulation, which, again, I'll talk about more. What are my lessons? Because, again, I'm leaving, but I'm expecting you guys to stay here and keep up the fight. Leadership, I think no one can dispute that Dr. Gilmore was a strong leader, but definitely having top cover and guidance is you. So what the new director is going to be like, but I do believe having the memos that we have already in place and the temp guide is definitely the framework for continuing to do science methods and T&E. Communication, that was me. Dr. Gilmore sort of did top-down memo, and then I worked with IDA and all the OTAs to figure out how are we going to do this. Can it be an Excel spreadsheet? Does it have to be in the temp? Can it be in the test plan? And through the little details of actually doing it. And partners, without NASA, they taught us the statistical engineering, and they taught us that you can actually have one sample size, or a sample size of one, and learn something. And universities, they've been great partners too. I know ODU down near Cardiff has been helpful, in addition to the research consortium. Sometimes you just have to do the best you can with what you have. Of course, I like to design a test with all the factors that we think are important, but sometimes the test scope has already been decided by the PM, and you're going to get 6 shots, or you're going to get 12 shots, and that's it. So use your techniques to best allocate what you have. Because I saw that each of the services implemented be a little bit differently. Factors, plots, split plots, combining, two factors into one factor. These are all things that came from the T&E community that we adopted and kept as best practices. That was really important, I think. The case studies, right away we had some, look, this is how we did it, and it worked. So put it there really helped. And then supporting the workforce. Here I'm, with the training and the specific developed training classes. In any time an OTA didn't understand Dr. Gilmore's memos, if they wanted me to come, I would come. We've offered our training classes in many places besides the OTAs, and so we're here to support those of you out there doing the work. And so I just wanted to skip through in slide 21. Let's skip on to 22. I just want to just give brief examples. So what did that get us? We did all this chart and roadmaps and meetings, and so what did it really get us? So this chart here on slide 22 is a chart we did very early on, but I think it's useful to show, in the dots, we just measured a response variable and all those different conditions. And actually, with the red dots, we measured the responses and those different conditions. We had used experimental design. What would mean that all experiments are designed, some poorly or some better than others. So anyway, this one was actually designed with a statistical model in mind, so that when we did the analysis, data gathered under factor A actually contributes to our knowledge of what happened under factor B. So you can see that with the red confidence intervals are actually smaller than the blue ones, even looking at the same number of data points and the same factors. And then I think is the best example here is the black dot, the roll up. That's what the report, maybe not even with the confidence interval, was the black dot, instead of the whole, all the red dots with the confidence intervals, which gives you so much more information than that last black dot. And my example of that is was a missed warning system where we, the requirement was, probability of detect of 0.5. I'm just making this up, but we reported. But when we actually went and looked at A, B, C, D, there was one of those factors where it was 0, and that particular factor was really important for the third that the system was going to. And had we not looked at the different factors, the car would not have realized the software problem, and the system would have been used in combat and not in a very critical condition. So being able to do a statistical model and use factors is informative. That's, I think, the key thing that we learned. On slide 23, then even the next thing is, instead of just looking at the factor effects, now we're able to actually see factor interactions. So this is an example from an actual Apache FOT&E, and it's looking at link 16 and looking at battlefield density. So the time to find a target with and with link 16 and high and low battlefield density. So you can actually see that these two factors are having an interaction. Again, without using a statistical model, we wouldn't have been able to see this type of interaction. And maybe this is completely obvious to anyone who thinks about it. Still, this is, I think, a good example to show what a two-factor interaction is. So my time is getting short here, so I'm going to skip on to the path forward, slide 24, 25. So I'm just going to quickly step through the next slides, but here's on using Bayesian methods to combine information across a family of vehicles. So here looking at reliability, looking at pairs of green and red as a different vehicle. And the traditional way, how we actually reported it in our report to Congress is in the green dots. Then actually using a Bayesian model to combine information from the different models that are similar because the same family of vehicles shows you that you can get a lot life or better information than, error bars that are over 10,000 miles wide. I think I had a note here. This is obviously the holy grail of reliability testing, is being able to use all the data. Next chart is surveys. So sometimes you have subjective outcomes. I said earlier, the whole purpose of OT is to measure accomplishment and to characterize mission accomplishment across its environment. But the result of that measure is subjective. It's basically opinion of the operator. In this particular example, I'm showing a Predator, or actually it's an Army system, so it's a Gray Eagle, unmanned aerial vehicle, and he's passing, in the operator screen, you see there's somebody who's flying it, who's looking at the video, but he's not actually the person that needs the video. The person who needs the video is, the commander that's over in the top right, worried about that situation. So we would use, in this case, a survey. And we use, as showed here, a Likert-like scale. We can actually treat that as a continuous variable, and we can do statistical analyses on the results. 27, I've just summarized here what were the key concepts for improving surveys. And I give my little foot stomp on why surveys are so important for operational testing, because OT includes the operator. And so survey of how the operator feels about that system, very important. And so it needs to be appropriately designed, it needs to be appropriately administered. You need to figure out ahead of time what survey do you want to use. Do you want to use one that has a score, like the SUS or the workload, or do you do a custom survey based on specific things that your system does? And finally, I think use of views and focus groups are good, but because of the dynamics and groupthink, we really wouldn't use those to report an actual answer, but you would use it to sort of identify our problems or have some more diagnostics on problems that came out maybe in a different survey, even in the performance data. 28, again, trying to speed up a little bit here. Okay, we're talking about modeling and simulation. Obviously, we already use MS and OT, and it's only going to increase systems increase in complexity, and we're doing system of system testing, and more M&S to our OT results. But these simulations need to be vetted, or at least the validation needs to be well understood when we're reporting results from a simulation. And because the simulation is going to be done in the simulation is going to be looking at the more difficult threats or the things we can't do on the range, and we're taking the model that we validated, say on the bottom left here, and then we're extrapolating up to the top right, and we really need to understand what is the uncertainty when we're doing things like that. 29 again just shows that possible those blue dots should up with the actual test that you did, so that you can understand and build a statistical model to help you with your validation of your M&S. Again, this is something we've started just to the tip of the iceberg on this, so I'm leaving this for you all to solve, but I know you will do it. When we start in that build, which I was just saying is that the live testing really needs to encompass some of the points that are in the model or the simulation. And again, the roadmap, the things we discovered along the way, it's basically just about improving OT. Not that we were saying it was terribly bad before, but we'd like to get better, get more efficient planning, more information out of what we have. I'm going to say do more with less. That doesn't usually work, but with a certain amount of resources, let's use them efficiently. Get actually more information for the decision makers. So that's soapbox pitch 2, and onto the very last slide. Oh, this is a build. So the things that I'm putting here is what I think are going to be challenges as we move forward. Space is very important, and how to portray combat in space. We basically don't have that capability now, but contested space is there. It exists today, and we need to figure out how we're going to evaluate that. Cyber's now. I think we've made a lot of improvements in the ability to do cyber testing and actually doing cyber testing. Since 2010, I don't think we were really doing it, not on acquisition systems anyway. Continuing to do and improve cyber testing is important. Autonomy, that's the word of the year. But there's all different kinds of autonomy, right? When we start getting into cognitive learning systems, I don't think any of us have really figured out what is a test program for a learning system going to look like. Good food for thought. Gathering terabytes of data out of our tests. Are we using it properly? Can we use it better? Can we use, for example, in the surveys? Can we start using survey data to start predicting, how operators are going to like systems? So using data, I know it's another buzzword, but that's I think that will be useful in T&E. And then workforce, always support the workforce. And I'll leave on another quote, which is to you all, that a small group of thoughtful, concerned citizens can change the world. And that's it for me. If you have any questions, I'm happy to take them, or he's going to tell me what they are.
Stop sharing your monitor to see if any questions came up. Right. No questions. Anyone in real quick?
Hit me in Italy. Got a big place. Right on the med. Yes. DOE lessons learned guide has studies, and the roadmap that we published in 2013
has technical.
Has, yes, some of them, but I think this presentation, no, this hasn't been posted yet. I can post it on the DOT website.
And it will be available on the webinar website too after we're done. So.
Audio too?
Yeah,
okay.
And there'll be an audio recording.
So I'll put this on the DOT website, but it'll also be here on the webinar website.
All right, no further questions. I'd like to thank Dr. Warner for all of her efforts.
My pleasure.
And advancing really the capabilities of the community, and it's been a pleasure working with you, and I know many people on the phone would say the same. So thank you for doing this seminar as one of your last actions as the science advisor to DOT&E.
Well, like, as I said, it was my honor to work with all of you, and you're the ones that did the work. I just did a lot of briefings. So thank you, and thanks for tuning in today. Appreciate it.